There we go. All right, we didn't have any video for a while. All right, hopefully we have, it looks like we have audio and video now, so that's good. All right, so we've got a couple of people online. Today what we're going to do is we're going to look at some first layer adhesion, so make sure that you can actually get parts to stick to the printer. We're going to overview the whole FDM process, like what is going on when we 3D print in the FDM. Remember, FDM is fused deposition method or fused deposition modeling. That's where you take filament, you know, like here's a little piece of filament, and you heat it up past its glass transition temperature, and it comes out of a nozzle. Nozzle could be different sizes. Typically it's 0.4 millimeters, and then that nozzle traces a pattern onto your print surface. Hopefully it sticks to the print surface, and then you can build up layer by layer different parts. I did assemble our printer, so I printed this little guy. It's a little elephant. This part is the support material on it, so you can print things that you think you wouldn't normally be able to. Maybe it looks like you'd have to print in midair or something like that. You can tell your slicer to add support, so that anywhere that there's going to be a part just hanging out in midair, it prints a removable support that can hold it temporarily in place, and then you break. This is a breakaway support, so you break it away later. There are other kind of supports that we'll talk about later on. With this particular style of printer, the other types are not typically used because it requires two different nozzles or some way to change filament so that you can have the support waste material easier to remove from your model. But this printer is not really set up for that, so we'll have to bring in some other printers, or at least look at other printers to have that option. So, but all of your printers have this option where and you don't have to design this yourself. Actually, you can. If you're designing from scratch a part, you can intentionally design breakaway support material so that it's exactly the way you want it. But this is just kind of an algorithm that designs a little support structure for your part that you're trying to keep. And then later when you're done, assuming you've got your settings right, there are some settings in your slicer that can affect how well this support is attached or not attached. Obviously, too loose and it's not really doing anything, and your part sags anyway. Too tight and it becomes part of your part and you can't get it off of there. So there are some optimizations. Now, I'll say this print and this support, I just built the printer. Remember, we're using the Ender 3. So here it is. This is our one that was in the box last time we looked at it. I didn't do anything. There's no upgrades. There's no mods. I did go and was pretty particular about getting the bed level, what they call level. It's not level like with a bubble level that you would use to check if a staircase is level or something like that. But maybe a better word would be trammed. That would be more on the CNC, like a mill type of approach. Those words would be more like what we're doing here. But we say level, and what we mean is that this bed moves in a plane that is parallel to our other axis here and perpendicular to our z-axis. So parallel to our x and perpendicular to our z, so that everything is level, meaning that the nozzle, I actually have a close-up of the nozzle. Where'd it go? There we go. So at the nozzle, there's our little nozzle. It's kind of out of focus, but maybe I can force it to focus on it. I don't know. But there's a little nozzle. That the nozzle is a consistent height from the bed. Speaking of that, let's talk about this first layer stuff. So we'll go back over here. The first layer adhesion has to do typically with one of three things, or a combination of three things. One of them is how far is that nozzle from your bed surface. So you're going to have a routine where if we go to our side panel over here, or wherever yours might be, there's a motion. Now I'm reading off the menu on this screen, and yours is probably got similar words, but it may not be the exact same words. Or maybe you interface with yours through your PC somehow, and that's okay too. But motion, auto home is the option here, and I'm just clicking the button. And so now we can see it's hitting all those little clicky switches, trying to find where home is. So now it's doing the Z. Now if we look where it's actually going to home, it's right on the surface of the bed. So that's 0, 0, 0. Now it looks like I might be slightly off the edge here. So maybe 0, 0, 0 is a little bit too far forwards. That's okay. But I'm not going to print that close to the edge. But, or at least I don't plan to. But how you change this. So let's say that it was floating way high above the bed, or it was digging down into the bed or something like that. Then what you would need to do is, you can see the corner of one of them over here. This little wheel back here, there are 4 wheels typically on these print surfaces. Sometimes there's only 3. Sometimes there's none, but we'll get to that later. Most of these printers are going to have 4 wheels that you can turn. And I want these wheels to be as tight as possible. There's one on each corner. I want them to be as tight as possible because I don't want the bed to be very loose. I want it to be as rigid as it can be. And so I want them to be as tight as possible, but I want them, if I go over here back to my menu and turn motors off so that I can actually physically move this around. Like right now, it's all locked in place. I'm going to turn the motors off. And now I can manually move things around. So what I want is, I want to have that nozzle just right at the surface of my print bed. They usually give you something like, a little piece of card that you can slide under there. I actually don't use that. I just look at it and get down eye level with the bed, kind of like over here, and get down eye level with this and try to determine exactly how far off of the bed is that nozzle. Now you do have to be careful, because if you're pushing on the bed, you can actually deflect it a little bit, so you don't want to apply any force to the bed. And I put the nozzle over one spring and I adjust it. Then I go and put the nozzle over a spring over here and I adjust that spring until it's right on the surface. Not scraping it, but a few fractions, not millimeters, but fractions of millimeters above the surface here. And then I go to the back and do the same thing. And then I go to this corner and do the same thing. This screw is usually a little bit difficult to adjust because it also has this bracket for holding your wires that go to the bed. The bed has a heater wire, or a set of heater wires, and a set of thermistor wires, so it knows the temperature of the bed. And then I'll go to the center of the bed, so something like this, and I'll make sure that the center is more or less the same as the others. Sometimes you'll find your bed is not flat. It's bowed up, or it's cupped down, and so it's not a flat surface. And so you just kind of have to even everything out a little bit. Now, one thing I'll say is that I have not heated this bed yet. When you heat the bed, like you're going to print something, and usually this bed is heated to maybe 50 degrees Celsius for PLA, or maybe 80 degrees Celsius for PETG. This bed is aluminum sheet, and it's an 1/8 of an inch thick. So it will deform some amount when it gets heated. So you really should do all this leveling with the bed heated up to whatever temperature you're normally going to print at, because it's going to deform and then change its shape a little bit. So that would be a better procedure. Heat your bed up, then do this stuff. Auto home, so do auto home, and then release the motors. Over here, motor off is what it says in my menu over here. Sometimes it says steppers off, something like that. And then go around to each corner. You can actually see there's that spring. I've got it almost all the way compressed here, so that it's not very springy. It gives a little bit, there's a little bit of give, but not a whole lot. If you end up in the situation where you're having to raise the bed too high, and your springs are just kind of floating there, they're not really offering much stiffness, they're very bouncy, you can, and let's see, how am I going to show this? Probably, we'll try and get this camera view down to it. It's going to be in the way. Oh, there's the edge of it. Can't really get down. Maybe the nozzle camera will be easier to get down there. Let's go back to it. Let's see. Right there. So this little bracket here, when you built that part of your printer, or maybe it came assembled, there's a clicky switch on the other side of that bracket. That is the one that determines where the Z equals 0 location is. And so you might have to loosen that bracket and move it up a little bit higher. On these particular printers, on the Ender 3s, if you put the bracket in without modifying it, it kind of locks it in place. It's got a little tab on it. I usually cut that tab off with, you know, the little, oh, where are we at? These little guys, so that I can have more adjustment, because I like the springs to be really tight on these printers. I don't like them being bouncy. I want them tight so that when the bed is moving back and forth, it's not bouncing around with, you know, sitting on these 4 springs. I want it to be able to move back and forth, be slightly compliant. We might even replace those springs with solid mounts later on, but slightly compliant, but really pretty solid, so that I can print at higher speeds without a lot of vibrations happening. All right, so that's the first step, is you have to get the nozzle right on the bed. When it thinks it's at 0, 0, 0, so when the printer, you've homed the printer and it thinks that it's sitting at Z equals 0, then you want the nozzle to be basically right on the surface of the bed without digging into it. Because your printer, your slicer, is going to print your first layer with the nozzle a little bit above the bed, you know, 0.2 millimeters or whatever above the bed. And if it's already above the bed and then it raises up higher, you're going to be basically extruding filament and just letting it land on the bed, and it's probably not going to stick very well. If you've got the nozzle too close to the bed, it's not going to have room for filament to come out. And you'll hear clicking sounds because the extruder, the feeder, is having trouble pushing filament out of the nozzle, and nothing can come out, or it's super thin, and it's almost stuck welded to the bed and it's hard to get off of there. So there's this fine range of distances where you're not too close and you're not too far away from the bed. Usually, if you're having trouble having parts stick to the bed, it's because your nozzle is too far away. And then you either need to loosen these screws to raise the bed up, although that makes them a little more bouncy, or you need to change the, well, it's off the screen now, but change the location of the Z end stop, that little clicky switch, so that your Z equals 0 is triggered at a lower spot. You know, move that switch down some so that it will take longer for the nozzle it'll drop lower and closer to the bed before it hits the end stop. So those are one reason, but there's 2 other reasons that could cause things to not stick. One of them is you've printed a part, you know, you've got your, where'd it go? Got your little, I think the name of this on Thingiverse is undistinguishable elephant. Not indistinguishable, undistinguishable elephant. So you got your undistinguishable elephant on here, and then it's finished printing, and you want to remove it off of there. So you get your scraper, and you're touching the bed and everything, and you have gotten oils from your skin onto the surface of the bed. So that will definitely cause adhesion problems also, even if you have the bed the right height. So I usually use something like this. So this is the IPA, this is the 91%, so it's the little bit higher percentage. It doesn't really matter if it's 91 or the 70%. Certainly don't have to have the 99 or whatever percent, the expensive stuff. This is like the $1 or $2 from the grocery store kind of thing. And you just get you a paper towel. Do I have one? Maybe I have one. Maybe I don't. Oh, here's one. Get you a paper towel and, you know, put some on here. This stuff evaporates really fast, so you can just clean off your print surface. Now, I've got the nozzle in the way here, so I'm going to raise it up so I can get under there. I just turned the Z-axis screw over here to raise it. So you clean it off with that IPA. Now, there's not a whole lot on there. Looks like one tiny little piece of trash is all that was on there. But this is, I haven't used this print surface very much. It's brand new because the whole printer's brand new. And then this will evaporate and you should have a pretty clean surface. The IPA is usually what I use. Most of these surfaces, that's fine. Actually, all of the surfaces I can think of, that's fine for using IPA on. If you use acetone, so acetone is not isopropyl alcohol. It is a stronger chemical, like it'll melt some of these plastics. You can't use that on all print surfaces. So be careful if you're thinking, oh, I'll just use some acetone because I have that. Then make sure that's not going to hurt your print surface. Now, this kind of surface, it'll be fine on glass. It would be fine on, but there are some that are coated with materials that the acetone would eat away. So this stuff is cheap, and I just use it. So cleaning. So now we've got the bed level, meaning that the nozzle is equally spaced all the way around on the print bed as best as I can. You know, this bed could be warped a little bit. I'm pretty sure this one has a low spot in the middle, and I had to kind of adjust the corners, so maybe it's a little bit closer on the corners, but better in the middle. But most of the stuff I print is going to be in the center. I'm not going to print too many things that are really large, covering the whole bed. So getting it level, cleaning it. So I actually do that every print. Now this, usually I actually use the, instead of this particular bottle, I use the little individually wrapped wipes that you can get. You can get like 200 of them for $5 or something like that, and you peel them open, and then you can wipe down the print bed and throw it away. Oftentimes I use that, but I've used them all up right now, so I don't have any. So if you don't have those or don't want to get those, this is easy enough. All right, so those are two reasons it could print. The third reason is your print surface might be too cold. So depending on the material you're printing, some materials need that print surface to be hotter than others. So PLA, which you're probably printing with, needs this to be, I usually have it at 50 degrees Celsius. That's decent temperature. PETG, if you're printing PETG, I usually have it at least at 80. Maybe higher than that. Some of these beds won't go much higher than 80, but at least at 80. So it could be that your bed is just too cold. You've turned off heating. Now PLA will actually print with this completely off, but it does stick a little better if this is a little hotter. If you have changed this surface, so this is the default surface that goes with it, but it's just clipped on here with these little binder clips. If you've changed it to something else, a lot of people will put a glass bed on here. If you've done that, then all of your print surface bed temperatures need to be higher, because now it has to transmit the heat. The heater's on the bottom here, and so it has to transmit through that glass also. So if you've added glass to the top of this, then you might need to go up another 5 degrees. So instead of 50, go to 55. Instead of 80, go to 85 to get that temperature right. If none of that works, so you're pretty sure you've got it, actually those all should work, but maybe there's just some reason yours still isn't sticking. There are other things you can do. So other things you can do include glue stick. So I just have a little glue stick here. When your bed is heating up, you can apply the glue stick directly to that surface. I don't like this as much, although it does work. And there are some materials that instead of helping this stick, it actually helps the material remove later on. So like PETG can get really stuck on glass, and so you might need this glue stick as a release agent for PETG. But this glue stick will help. The only downside to it is that it does leave residue on your surface here, but these are water soluble, so you can wash it off later. And it'll leave that same residue on the bottom of your print. So that's the downside to glue stick. I more often use this, just the purple can super extra hold, or no, extra super hold Aquanet hairspray, and just let the bed heat up, spray it on there. The nicer thing about this is that it will self-level a little bit, and so it doesn't leave quite the same gunky mess on the bottom of your print, although it's still going to leave a surface on your printer. They do make purpose-made things. So here's Bed Weld from Layer Near. It's a, let's see if I can get it open, thing probably from Amazon is probably where I got this. And if I can get it out of there, you know, it's got one of those type applicators, sort of like a glue stick, except it's a foam tip, and you put it on there. Usually these, they want you to have the bed heated. Let's see, shake bottle, squeeze bottle to release, blah, blah, blah. Heat your bed to 60 degrees until the coating is dry. Once dry, it's ready to print on. This particular one is good for PLA, ABS, ASA, and PETG. There are some of these that are specific to certain materials. This particular one is supposedly good for all 4 of your primary materials. Doesn't say nylon on there. We'll try to print nylon sometime later. But those are other things you can do to try and get stuff to stick down. That's usually not so much a PLA problem or even a PETG problem. It's usually more of an ABS problem, or maybe a specific geometry problem. So you've got a part that just keeps wanting to peel up, or maybe it's got really low surface area and it just doesn't have a lot to stick on here. So in those geometry problems, there is an option. Let's go to Cura. I think Cura is running over here. Let's see. Yes. Let's go over here to Cura. That's not Cura. Cura would be, where's Cura? I don't remember if I have Cura running. There we go. There's Cura. All right. So let's actually make it where I'm not covering it up. There we go. So over in your options over here, if you look for, it should be one of, I'm on, what am I on right now? I'm on custom. So let's go to basic and see if it's in basic. I don't know. Oh, it is. All right. So if these little 3, you know, they call them the hamburger, these little 3 lines will let you change the amount of information you see in Cura. So if basic is the minimal amount, like temperature, layer thickness, stuff like that. If you want to see everything, there are hundreds of settings, individual settings you can tweak in Cura, your slicer, to get exactly what you want. Or you can search for a particular thing over here. But it looks like build plate adhesion is one of the ones in basic. So here are 3, well 4 if you count none, 3 options for helping your print stick down. Let's add a part and show you what they each do. Here we go. These are little tire. Oh, this is a cool print. These are little tires for a little Jeep you can print and assemble, kind of like a model kit. So, but it's tiny. It comes on a, you know, a little sprue and everything. So these are little tires for it. And so they don't have a lot of surface area, and they might have trouble sticking down because, you know, they're only going to be touching the bed in a really small area here. So now I didn't have any problem. I printed them exactly like this and they stuck down fine, but maybe they don't want to stick down. Maybe they want to peel up or something. There are 3 things you can do in the slicer that will kind of help with this adhesion problem. So skirt doesn't directly help with the adhesion problem, but let me show you what it does. So I'm slicing this, and I will preview this track around here. That's called the skirt, and it doesn't obviously it doesn't do anything to the parts you're trying to print. They're just sitting there inside of this skirt, but it does do two things. One is that it shows you where your part's going to land on the printer. So if it's in a bad spot for your print bed, you can say, oh, that's not going to work, and you can move it somewhere else. That's not as common, but the other thing it does is it gives you, like, this is set to 3 layers. I don't know if you can, 3 rounds around it, like little tracks around it. And so it gives you those 3 tracks around there to manually adjust the knobs on your printer while it's going. So while it's printing, you can go in there and you know, oh, it's too close on that corner, so you tighten that knob down. Or it's too far away on that corner, so you loosen that knob to get the bed higher. So that's one way, and I do use that. I usually print with a skirt because it also purges the nozzle. You know, it gets it primed, ready to print when it gets to the actual parts you want. All right, brim. So let's slice and look what a brim does. So a brim adds actual material to the part. So you have to cut this off when you're done. Usually it'll peel away pretty easily, but you may have to get an X-Acto or some kind of tool and remove it. But it adds a whole lot more surface area to the outside of your part. So if you have little tiny parts that just won't stick, a brim might be the way to do it. I do use brim sometime, particularly if I have a corner that keeps wanting to peel up on the print, or really tiny parts. This next one I don't use too often. It's kind of my last resort, but it's called a raft. And it literally prints like a whole new surface to print on top of. So this is good for small parts, or it can also work for parts that your bed has some damage on it maybe, or it's really badly warped. This raft will cover over all that stuff, and then you print on top of the raft. So, but the downside, look at this. It takes 32 minutes to print this, where with the skirt, it was 17 minutes. So it takes twice as long. You know, half the time I'm printing, I'm not even printing the parts I want to print. So, it takes twice as long to print. Well, not twice as long to print the raft. In this case, it takes twice as long. But, it does add a significant amount of time just printing this raft that you're going to throw away. But it is a kind of a last resort option. I usually use it if I'm printing very tiny parts. And I don't want to, you know, they're so tiny that I don't want to try and remove a brim from them because I think they'll break. But they just keep not sticking to the bed. So I'll print a raft and let them stick to that raft, and they usually come off of it pretty well. So those are all the various ways that you might deal with poor first layer adhesion. There are some test prints you can use to try and print patterns on here to adjust the bed while it's printing. Let's see if I have one in here. Let's see. Bed level calibration. So you don't have this. So I'm in extension. Let's get this part off of here first because it's going to be in the way. All right. So I'm in extensions up here. Can you see that? No. Let me get that on the screen. All right. So extensions. Now I have added this one called part for calibration. You don't have that, but over here in the marketplace, you can go, you have to be connected to the internet. You can go and set for, I think, search for calibration maybe. Oops, if you spell it right, that would help. That's not it. Let's see, what is that one? What if we just look for parts for calibration? No. What if we just look calibrate? All I'm seeing is auto towers. So I don't remember the name. Let's see. What are my plugins that are installed? Can I see that? Part for calibration. Doesn't say its name here. Oh, calibration shapes. That's it right there. So if you search for calibration shapes, well, maybe it's just called this now. I don't know. Maybe you have to search, and I don't know what's going on there. I'll have to look and see why, because this one is specific to towers. But there is somewhere by 5-axis a calibration shapes plugin that adds those options. So it adds all of these parts here. One of them is a bed level calibration. So if I add that, it literally is. You could make this if you wanted to. If you can't find the extension that does this, then you could go into Tinkercad or SolidWorks or whatever and make it some squares with some lines in between them. But it's just a part. It's just a geometry that you slice like you would any other part, and then it goes and prints in each one of these corners, and you can see which corners are too close or too far away. What you're looking for. How long will this take to print? Let's see. We don't want any support build plate on it. I'm off the screen here. 14 minutes. It'll take 14 minutes to print. Why don't we do that? The problem is, on my machine over here, I've got some PETG loaded, and I don't want to print this calibration thing in PETG because I don't have a whole lot of that. So let's find some PLA somewhere. Well, first let's show how to load and unload filament. Maybe you haven't gotten that part done. So what I'm going to do to load and unload filament is, since this is PETG, I'm going to go over to my menu over here, and there's a temperature, and I've got preheat. Actually, I only have preheat PLA and preheat ABS. You might have preheat PETG. I'm going to preheat ABS because that's closer to the temperatures I need than the PLA. PETG, you usually print around 220 or 230 or something like that. This is actually going to print it or heat it up to 240, which is fine. We'll heat up our nozzle so that we can get the old filament out, and then we will put some new, here's some green. We'll put our new green Matter Hackers PLA in. So it's about halfway heated up right now. It's getting there. And just maybe you haven't changed the filament yet, and so they'll show you how to do that. Okay, you couldn't find the shapes either. I don't know how I downloaded that particular one a long time ago, and so maybe I just have I'm grandfathered in. I don't know why calibration shapes is not in there anymore. It does say search in the browser, so I'm going to click that this time while we're heating up and see if that does any difference. I don't actually. Oh, it opened up a new browser. Okay. Let's see what happens. That's not doing anything. Calibration shapes. It still doesn't show up. Huh. Really? I wonder what has happened to that. Interesting. Well, I'll search around and see if I can find where these plugins might have gone, but that's interesting that it's not appearing there anymore. So yeah, it could be discontinued, although it still works in this version of Cura. Although I did notice when I've started this version of Cura that it said that I needed to upgrade, so maybe, or well, I didn't need to upgrade, that there was an upgrade. So maybe the newer version of Cura does not handle those extensions the same way as the old one. So I don't know if I want to upgrade because I like my extensions. All right, we're heated up over here. So we're at 240. So that's plenty hot enough for PETG. It's probably too hot for PLA. We'll talk about that in a minute too. What I usually do is I go over here and you've got your tension arm, and I do that, and I don't pull out first. I actually push in for a little bit to kind of get the filament that's at the very tip of the nozzle softened up, and then I pull out. So I push in a little bit, and then I pull it all out. And then you'll end up with a little knob on the end here. It's not going to focus on that. I cut that off because it's not going to go back in very well. So cut that off at an angle. If you cut it off at an angle, then it'll re-enter simpler the next time you use it. Now I don't have a lot of this left, so the next time might be the last time for that one. Alright, so same thing for the green in reverse here, except that I'm going to drop the temperature because 240 is really hot for PLA. I'm going to go down to 205. So what I did there on the menu was I did temperature. Instead of preheat, I just changed the nozzle temperature directly. So the second option here is nozzle, and I'm going to go to 205. Okay. I'm going to find the end of this. Here it is. Now this end is cut off straight. I'm going to cut it off at an angle because that does help it enter the hot end a little bit easier. So, and then just chopped it at an angle. My nozzle is down to 204 now. So now we're gonna, sometimes this part's a little bit tricky getting it to line up with all these holes in here, but if you twist this, you know, all of the filament is on a spool usually, so it's already at a curve. So if you twist it as you're turning it in, you'll usually get it to line up with the Bowden tube. Or if you want to say Bowden tube, that's okay too. I think it's technically Bowden, it's a person's name. And then I just feed it in. Should have some filament that comes out here. Now, I was printing with black PETG, and this is a green, so I'm need to extrude quite a bit of filament to get the green, if I'm worried about that. So, and I kind of am, because that black in there is PETG, which melts at a hotter temperature. So I want to clear all that out. And I'm just going to do motion, move axis, and I'm going to move the extruder, and I'm just going to extrude, I don't know, 30 millimeters of green. So you should see the green being pulled in. I mean, you can't see it, but you could feel it. And out here you can kind of see it's going from darker, getting lighter, turning into green, and it looks like now I've got pretty much just green coming out. Okay. Oh, that's an important point too. If you have already printed something and then you go to level your bed, make sure that you clean off the nozzle, because there's probably a little blob of filament stuck on there. And that little blob of filament will alter, you know, you looking at the nozzle, you think it's part of the nozzle, or if you're just feeling it, then it will feel like part of the nozzle. So either clean it off, or heat up your nozzle and your bed when you're leveling the bed, so that you don't have that little blob on the end of it. It'll just be melted. All right, so now we've got our PLA loaded, and it extruded all green looking. So let's go over here and let's get our. I'm using the no-name SD card at my own risk, but I don't think I'm too worried about this particular part, so it'll be all right. So I've got those two Jeep files on there already. I'm going to save this one. Be sure you do eject these. So Cura will automatically tell you to eject, but if your slicer doesn't, it is way better to eject these instead of just pulling them out. They do get corrupted easily, It seems like. So now I'm back over here. There's a little SD card down there. On my menu over here, I am going to return to the beginning and print from TF card. So untitled. I guess I didn't. Yeah. So yeah, I never named that thing, so it's just untitled. And we'll start to print. So the nozzle's up to temperature. The bed, it looks like it's going to print at 70. Wow, why don't I have it? So, whoops, hold up. All right. So let's cancel the print. Stop. Let's go back to Cura. And notice up at the middle here, I've got generic PETG loaded as my material. And I just loaded PLA. So I want to go back and change this to generic PLA. And let's see, layer height. Let's discard the changes because those are all for, I was printing those Jeep tires. So let's go back to our defaults. I should have checked them. 0.2 layer height. The walls are 2, that's fine. Top layers, we're only going to have like 1 layer, so it doesn't matter. Infill, there's not going to matter any infill. Printing temperature at 200, bed at 50. Alright, so let's slice that guy. And let's preview to just make sure we don't have any weird stuff going on. We do have that skirt. Let's not do the skirt. I don't want the skirt on there. So let's turn that off. And then reslice. Okay. Let's save to removable drive. Eject. Oh wait. Yeah, I guess it did. All right. We'll know when we get over here and see the temperature it wants to print at. It said the bed was going to 70, so I knew that wasn't what I normally print at. Alright, so now it's doing its homing routine. There's a little bit of stuff hanging off of here, so I'm going to move that. You have to be careful around there. That nozzle could be hot. It's currently 100 degrees Celsius. Now our bed is trying to get to 50, so that's more like what I normally do for PLA. Alright, while that's going on, let's talk a little bit about this whole printing process. So let's go over here. And somewhere I've got a pin back here, and let's just talk about particularly let's talk about FDM printing. And again, that is fused deposition, like you're depositing things. There should be an I in there, and we'll just say method, although sometimes modeling is the word there. Alright, so it starts with filament. Remember, there are 2 basic sizes. 1.75 millimeters is the most common size, but you could have 2.85. Usually we call that 3 millimeter filament. Most of the time you're going to have the the 1.75 filament. So since we have green, let's make a green. Let's make it there, and we've got this filament. It's coming off of a roll, a spool, or whatever, and it is a thermoplastic. That basically means that it's a polymer that doesn't like melt. Melt meaning like turn into liquid. It does soften though, and when it cools, it holds its shape. So thermoplastic. There are a few people trying to get thermosets to print. They're a different beast altogether, but they do have some nice properties. But pretty much everything that you're going to print with in the next year is a thermoplastic, assuming you're doing FDM printing. All right, so this filament gets fed into a pinch roller usually. So we'll just say that we've got, move it maybe right there. And there's actually 2 of these. Our print just started. So this is our pinch roller. And one of these has a force applied to it. So in the default setting on the Ender 3, the default setup, this one is just passive. It's just a little guide wheel type of thing, but it does have that lever arm attached to it that is pushing it into the filament. The other one has a torque applied to it from that stepper motor, and that's what's feeding in the filament. This is the brass one, so it's kind of, you know, gold colored or whatever. And our filament is pinched between these 2, and it's sent out into, for these type printers, it's sent out into a, what is it printing? Oh, it's just, okay. I was looking at the printer here, and let me show you what it's doing. It's printing this, and I couldn't figure out what in the world it was doing, but it's just printing in a different order than I expected. So it's all right. So that's weird. All right, back over here. No, back over here. All right, it's sent into a Bowden tube. So I'm just going to draw that as a tube here. These things are not specific to 3D printing. These things are like on a bicycle, the handbrakes, you know, the little cable goes through a tube, that's a Bowden tube. So it's just a tube for guiding some kind of cable, or in this case filament, so that you can compress it or push on it. Because if you just pushed on a piece of filament without this tube around it, then it would just collapse, right? So these tubes are meant for that purpose. So you've got some kind of cable or rope or filament inside this tube, and you want to be able to push on it and it go out the other end somewhere. So that's what this thing is. So the filaments travel inside there. Now I've got a large gap between the wall and the filament. The inside diameter of this Bowden tube, or Bowden tube, should be barely larger than the filament. So bad filament, which I haven't seen much bad filament these days, but bad filament could have, you know, bulges in it, and it would get stuck in this tube because a little section of it would just be too large of a diameter and it couldn't fit through the tube. If your tube is too large, that inside diameter, then the filament kind of gets all crinkled up in there. So the tube, you know, the tube on the printers these days is pretty good. There is a better tube that you can replace this with if you're trying to get really precise, you know, on your flow rates and things like that. You can replace this tube with a Capricorn tube. It's a blue tube that looks a lot like this one, except it's opaque and blue. And but it tends to have a tighter control on the inner diameter of that tube. So it gives you better control over the filament inside the tube. All right, so we're at the Bowden tube. Next, it goes into a heat sink. So there's a little coupler here, you know, and it goes into an aluminum block with fins on it. And this is our heat sink. So on this heat sink, there is a fan, you know, blowing ambient air across that heat sink. If that fan ever goes out and you're printing, you're going to have problems. So that fan on this printer, that fan is right here in the front, and that's where most of them are. I suppose there could be some that it's on the side or somewhere, but most printers, that fan is right on the front of that heat sink. Because the filament goes through the middle of here, and next it goes, well, next there's a little piece here. I'm going to extend it just a bit. This is the heat break. Actually, I think it's not that kind of break. I think it's that kind of break. And this is a metal component, usually steel, but you can get like titanium ones. And it's physically connecting the heat sink to the heat block. So this heat block, that's the 200-degree spot. Actually, inside there is a resistor. On these Ender 3s, this is 24 volt, and it's usually a 40-ish watt heater. So what would that be? I think that is 14-ish ohms or something like that. Somewhere in that range. It's just a resistor, and that's what heats up the heat block. The filament is going through there. If this heat break and heat sink weren't here, then the filament would gradually get hotter and hotter as it goes outside of the heat block, and the feeder, you know, our pinch roller up there, couldn't actually push it. It would just push it and it would just kind of crumple into a gooey pile. So I have to cool off the filament before I try to push on it. So that's what the heat sink does. The heat break just keeps the heat sink and the heat block physically separated. And then the last piece is it goes to your nozzle. Your nozzle is brass. So, you know, brass. But you can replace them with steel and other materials. And by default, this dimension 0.4 millimeters. So that's the generic FDM printing filament path. Some can have slightly different things. Some of them don't have a Bowden tube. They put the pinch roller basically right on top of the hot end, so there's no tube between them. There's reasons for doing that, and then there's reasons for using a Bowden tube. So as we get further in the course, we'll talk through some of the different reasons why you might do one or the other. Since we're using a Bowden tube printer here, we've got this tube. One of the reasons why you would want that is that this is the part that moves, right? And if I also had the feeder, the pinch roller on top of here, I'd add a lot of weight. And so this couldn't move as fast because it's got a lot of inertia that I have to deal with. And so one reason you might not want to have the pinch roller feeder on top of here is just to get that weight somewhere else. The weight is actually over here, kind of behind. You can see part of it right there. It's not moving at all. I guess it moves up with the z-axis, but the z-axis moves really slowly, so I don't have to worry about the weight of it on there. The downside is that I've got this long tube that can give me some difficulties. Mainly, it acts like a capacitor. So, you know, it stores energy in all of this filament here because I'm pushing on it, and it doesn't come out immediately. You know, there's some lag. And so if I want to stop printing, then all that energy, that compressive force that's in this tube will continue to cause filament to ooze out of your nozzle for a little amount of time. So I have to take that into account. I think last time on the video we talked about retraction. I have to suck the filament back up so that it doesn't ooze out. Let's look at our print. It's almost done. So we might have to zoom in a little here. Let's see if I can get closer. But how can I be... There we go. So what I'm looking... This is actually all looking really good. What I'm looking for is these squares. I want the lines in them, so it's printing them at an angle here. I want them to be touching, but not like overlapping so much that they're bulging. This one's getting a little bit little bit bulging, but not enough to worry about. But I don't want them so close together that that they're pressed too much into the bed. Like this one right here, I wish you could feel it, but you can't. So trust me that this one is thinner than these others. I can feel the difference in them. So this spot right here is a little bit too close to the bed, but and these two are a little bit also. So what I could do is, since this front row is a little bit too close, I could take both of the knobs under here and just turn them a tiny bit to bring the bed down just a little bit. And this one's pretty good. That one also is a little bit close, so I may have to bring that bed. Now, you know, if I adjust this, and it does affect everything, so you have to do little bits at a time. It's a little bit iterative. This one is definitely too close back here. so these corners need to come down, but I don't want the middle to come down too far because it's about perfect right now. So this is telling me that the bed is not flat. You know, it's got some waves in it or whatever. I'm going to have to make the best I can out of it. So the best I can is I'm going to turn these a little bit. I'm going to turn that knob quite a bit because once it's done with that, you'll probably be able to see that it's really thin. I think you'll even be able to see that on the camera. Yeah, this one I can tell too. So this corner back here is really too high. It needs to come down, and that's going to be typical because the screw that's attached to this corner is harder to deal with because it's not the same as the others. All right, so let's look and see what comes out of this. Oh yeah. All right, so let's see if I can get down there. Oh, well, it's gonna go back there. Now it's gonna come back. So okay, let's move that guy out of the way. So see how, all right, so see how that one is pretty much solid. There's no gaps in there. If there were gaps between the little lines, then the nozzle's too high and I'd need to raise the bed. So these are good, but this one, you know, you can't even see some of it. It's so thin that it didn't really extrude much filament there. Same thing on, well, on this corner. You know, there's barely any filament there. So this area is too close to the nozzle. So I need to tighten this screw under here, which is hard to do, but I'm going to tighten it a little bit and hopefully get this a little better. But I'll also try not to print many things in that area. So I'm going to see how well this peels up. In general, it seems like I'm a little bit close all around. That's not bad. It does mean that you might have some issues trying to peel things up. You know, that I can't get under there very easily. But once we get it started, it should peel up okay. Yeah, it peels off okay. These in the middle are pretty much perfect though. So see how it just peels up pretty easily. Those are pretty good. I'm making a giant mess over here, but everything is peeling up. Now these back in the back, we may have some trouble with those. I don't know, because they're basically part of the bed now. But we'll do the best we can. I know I'm shaking everything everywhere. And see, this is one of the things where if this happens to you, you're probably having to get your hands all on this. You're getting oil everywhere. And so you might have some adhesion problems if you don't go back. I got that one mostly up. If you don't go back and clean off the bed. This one is actually being harder. There it goes. So I've got some residue in there that I could probably scrape on and get off of there, but I might end up doing more harm than good. But we'll do a little bit. Okay. Let's go ahead and clean the bed since I know that it's got all kinds of oils on it now. So I got some fresh IPA. It's going to evaporate even faster now because the bed is heated up, right? That's okay. All right, so we should be good. And our bed is pretty level. I mean, it does have some warpedness in the bed. We do have ways to take that into account, even without adding any new materials, like a sensor on the side of the thing over here. We'll actually do that, but there are ways that we can manage this just in software. Let's see, what else did let's see, we have a few minutes. Let's talk really briefly back over here about a property of these polymers. So this is TG, and it is the glass transition temperature. Now, in general, these polymers are amorphous thermoplastics, and so in general, let's do a arrow here. There's a x-axis, and there's a y-axis. So on this x-axis, we're going to have temperature. We'll have it in Celsius. And then over here, we'll have stiffness is what I'll call it. So sort of like modulus of elasticity, something like that. But we don't need actual numbers on here. But in general, as a polymer like this gets hotter and hotter, this is what happens to the stiffness. So at some point, you know, down here, I am in what would be called a glassy state. It's not like it's literally glass. It's the room temperature state for this stuff. So I lost my little piece of filament. I don't know where it went now. But you know, it's solid. It's rigid. You can still bend it. It's still flexible. But it's called the glassy state. And then some point maybe over here to here, it gets into a rubbery state, and then this part of it is viscous flow. Now, if I'm printing and I want this material to come out of the nozzle and, you know, be kind of predictable, I want to be in the viscous flow region, but I don't want to be way over. I don't want to be way over here, right? Because if I melt this stuff too much, then it doesn't hold any of its shape. So I want to be really, you know, somewhere in this region for printing. The glass transition temperature is, some people will put it up here. Some people will put it in the middle of that S curve, you know, kind of in the middle of there. But there's some point where it's no longer a rigid material. It is gonna stretch. All your polymer chains are moving around. So these polymers, you know, they're made up of long chains of whatever material they're made from, and as they cool down, the materials contract and they give less space for the polymer chains to move around, so they enter that glassy state, and they sort of lock in place. They can still move a little, but they're not flowing. But as they heat up, the material expands, and now those polymer chains have room to move around, and they get more on the flowing side of things. And that glass transition temperature is the point where that stuff starts to happen. So for PLA, that's somewhere around 70 degrees Celsius. There's not like an exact number and it flips a switch. For PETG, which I had in my printer earlier, it's somewhere around 85 degrees Celsius. ABS, actually, let's put PETG somewhere around 80. You know, it depends on the additives. All of your materials that you print with they're not the pure material. They have plasticizers and colorants and all sorts of stuff inside them. So, you know, these are all kind of about numbers. ABS, I think, is closer to 90 or so. I actually might have to look that up. Let's look that up real quick because I don't actually know it. ABS, TG, glass, PLA, yeah, PLA is 60. What about ABS? ABS. What is it? That's fine. That's all fine. The numbers. Oh, all right, 100 to 110. So we'll put it at 100. Now, why this matters, because you're not printing at this temperature, right? But why this matters is it affects how your part will perform once you've printed it in different environments. So let's say that, and now these are Celsius numbers, so these are not Fahrenheit, but so Celsius numbers, so be sure you're aware of that. But let's say that you want a part that's going to be in a engine bay of an automobile. Probably PLA is not going to be able to, it may not like get over here to the rubbery viscous flow area, but if it gets past the TG, then it's still going to be able to, if it has any stress on it, it's going to be able to deform. And then when it cools down, it's going to hold that new shape. So you have to be aware of where is this part going to be when I'm done with it. Because that could affect the material that you need to use for that part. So if you need a lot of high heat deflection type stuff, then you might have to go to ABS. There's actually another material kind of in here called ASA that's newer, and I think it's also in the 9500 area, somewhere in that range. But it's easier to deal with than ABS. For now, I'm going to say probably you need to stick with PLA, and if you need a little bit more heat resistance, then PETG is a good material. Now, in the, let's see, maybe here? Well, in here, on Canvas, if you go to this Class 5 link, and I think I put it in the YouTube description too, so if you're on YouTube, I think it's there too. I gave you a lot of bits of information about PETG because it's the more, like, I don't know, it's not an engineering material necessarily, but compared to PLA, it can do a little bit more if you need the part to be functional. PLA is great for printing and for some functional parts, but PLA can be a little bit brittle. It's actually stronger than some of these other materials, but it can be a little bit brittle and hard to work with. Like, it's super hard to sand and finish if you need to do any of that. So if you need to do that kind of thing, then PETG might be the next material to try. And so I gave you some options here on just general ideas of how to do with PETG. The biggest thing is that it's going to need a hotter bed to print on, less cooling. Let's see. Not this cooling, but there's actually another fan. I guess I could put it over here. So let's say that I've probably printed thinner. So, you know, I've printed my layer here. You also have somewhere on your printer a little fan that's cooling off the part that you just printed. And that's called a layer cooling fan. Sometimes the part cooling fan. And so this fan is always on over here. If your printer's on, then this one's on because it's cooling the heatsink. But this layer cooling fan, you have control over. You can turn it off. You can turn it to 50%, 100%, you know, whatever you want to. In your slicer, you can do that, or we'll look at G-code to do that too. But this fan, some materials respond better to cooling right after the printing, and other materials need no cooling at all, like they need to cool naturally on their own, or else they'll split apart. PETG is in the middle of that. So It can be cooled, but it's going to be weaker. It's going to look better, like the surface finish is going to be better, but it's going to be a weaker part. Or you can have no cooling at all, and it'll be a really strong part, but it's not going to look very good. It's going to be kind of lumpy and gooey looking. Or you can do somewhere in the middle, like 50% fan. I assume that in Cura, if we look at our fan speed, let's see, cooling, actually, oh, because I'm on PLA. So this is the PLA setting. Fan speed is at 100%. Let's switch back over to that PETG setting. Discard the changes. Yeah, fan speed drops to 50%. So PETG needs a hot bed, 50-ish% cooling, and the rest of it prints just like PLA. It might be a little worse surface finish unless you do more cooling than what I've got here with the 50%. But in general, it's going to be somewhere around that 50%. It's got a good material to try. It doesn't cost any more than PLA. It doesn't come in as many. It probably does come in as many colors, but I don't know. They're just harder to find sometimes. Generally, the PETGs are either like this kind of dull matte kind of color, or they're kind of translucent-ish and sort of glassy, which is neat too. Let's see if I'm looking for a PETG. Let me get this part. So here, let's see, here's a ocarina that's PETG. So you can see you can kind of polish it up a little bit even, where you can't do that with PLA very easily. But PETG, you can kind of polish it and get, this is a solid part basically. The walls are solid, and it comes out, it just is different than the PLA, and it's a really tough material too. So it's not as strong necessarily, but it's tough if you understand what I'm saying with that. Okay, I think we're at a good spot for ending today. We'll be back Monday. I think Monday should be a live stream. Actually, all next week should be live streams. I don't see any new questions, but if you come up with something like, hey, I'm having trouble with this, or I want to print that, or what do you think about this, then send them in Discord or email, or if they show up in the chat, I'll try and answer them then. It's just, I may not see them. I only see 2 right now. But let me know, and we can always divert to some other topic related to 3D printing. All right, I will see y'all Monday.